of. What is John's new salary? Well, we said it was a 20% increase on his old or original salary, which was X. So what's a 20% increase on X? Well, one thing we could do would be to multiply X by 20% or else 0.2, and then we're going to add that to the original amount X. Or else we can just do this in one step and take 120% of X, or else 1.2x, and that would give us his new salary. 1.2x is just a 20% increase on X. So rewriting this once again, 1.2x plus $20,000 minus X plus $20,000 all over X, sorry if that's a little crooked, plus $20,000. Okay, now we've taken care of the writing. If we want to talk about writing expressions, we did that. Now we need to look at simplifying this expression because it's a little bit messy. The denominator is as simple as we can get it, but the numerator we can do a little work on. We need to take care of these parentheses here, and we need to distribute this minus or this -1 over each term inside this parentheses. Okay, so we'll do that now. I'm going to just rewrite this here. Take out the parentheses, 1.2x plus $20,000, and then minus goes over the x to get minus x, and negative $20,000. Okay, now some more work on the numerator. Hopefully you'll see that we have a positive $20,000 and a negative $20,000. So if we want to add those together, that just cancels out to give us 0. So we just cross those out there. Now we're left with 1.2x minus x over x plus $20,000. Okay, so that's gonna leave us with two like terms here. The x is here. So if we want to combine those like terms to simplify this, we just add together the coefficients and multiply by x. So the coefficients are 1 plus 2 and -1. So 1 plus 2 minus 1 is 0.2, and multiply that by x. So 1.2x minus x is 0.2x, and then keep the denominator the same. So that is our final simplified expression there. 0.2x over x plus $20,000. So now we've got a workable expression here that we can substitute any number in for x, representing John's original salary, and we can find the percent increase in the total amount John gets paid. So let's do that now. Let's try, let's say John's original salary were $60,000. So we're saying that x is $60,000. Oops there. So now what we just do here is plug in $60,000 for x in this expression there. So 0.2 times $60,000 over $60,000 plus $20,000. And that's going to give us $60,000 times 0.2 is $12,000. You don't have to worry about doing this part out like this. You can use a calculator if you'd like. 60,000 plus 20,000, and 12 over 80, if you don't know off the top of your head, is 0.15. So that's 0.15, or else boop boop, 15% increase. So that'd be a 15% increase in the total amount he gets paid if John had an original salary of $60,000. So you'll see that if his salary increases by 20%, his total amount he gets paid is only going to increase by 15%, and that makes sense because his bonus isn't increasing by at all, so it's not going to increase as much as his salary would increase. Alright, yeah. Okay, so that's a simple little plug and chug, as we say there. But let's get a little more complicated scenario here. So let's say Boring Corp decided to give a 20% raise to all their employees. So would this help the low paid or higher paid employees more? Meaning, would the lower paid or higher paid employees get a greater percent increase in their total amount earned? So we can plug in some numbers to find out. So here we already found out what the percent increase would be for $60,000. Let's try a little bit higher number and go $80,000. So let's say X is $80,000. Just plug into this expression up here. 0.2 times $80,000 over $80,000 plus $20,000. And that's going to give us $80,000 times 0.2 is $16,000 over $80,000 plus $20,000 is $100,000. And that's going to give us 16,000 over 11, or 100,000 is 0.16, which is 16%. So an employee that started out with $80,000 salary would get a 16% increase in their total amount. So you can test this out with more numbers if you like, but what you'll find is that the higher the salary, the more percent increase an employee will have in the total amount they get paid. So it'll get close to 20%, but never quite reach it. So our conclusion is that lower paid employees wouldn't get as much of a benefit in their raise as higher paid employees. There's a lot more scenarios we could think about with an expression like this, but I know I've taken my fair share of time and then some. But you can plug in some more numbers if you'd like. So you can think of evaluating an expression and plugging in different numbers as a reward for the work you put into writing out and simplifying an expression, because that was a lot of work. But you wield an unlimited amount of power with an algebraic expression, not only to be able to get values for any situation, but also to be able to interpret those values like we just did there. So now that we're done with expressions, we're going to move on to equations. That's when things will really get exciting. So I'll see you guys next time.